more fitting, like a more apt description of what actually happens with LLMs than hallucination. So I'm just gonna go with this terminology. Um, these are my own categorizations of LLM guardrails. It's not, I don't think you're going to find it on any other official resource. Of course, it's up to debate. I just found that any type of guardrail that I could find is a subgroup of these big three. Awesome. All right, syntactic rails. What do I mean by that? Okay, so there are two ways to go about syntactic rails. You can have constrained token generation. So you're making sure that the syntax of your output fits your requirements at the generation time. I'll explain it a little bit more in detail. Or you can go with validation. Okay, so validation, this is post generation. Once you have your actual full output, this is where you're gonna have to go with a validation approach. Now, constrained token generation with context-free grammar. Okay, so context-free grammar is a set of rules that defines a language where any expression can be resolved independently from context. Okay, so this is basically what allows us to constrain tokens at generation time. I believe llama.cpp and others, maybe outlines, are examples of libraries that implement this sort of approach. But basically, at the last layer, or rather after the last layer of a transformer or of a transformer decoder architecture, NLM, what you get is a vector of logits, a set of unnormalized probabilities, one for each token, each candidate token for the next generation. And what you can actually do at that point is penalize the probability of each token dependent on its compliance with your regex pattern. Okay, the regex pattern, which in this case is a way to apply your context-free grammar rules. Okay, so any token that doesn't fit your pattern is immediately put to minus infinity of probability. So that's one way to apply syntactic rails at generation time. And what does it apply to? Well, any language that can be considered as a context-free grammar. So you can think of JSON, SQL, YAML. Okay. So on the opposite end of context-free grammars, you also have context-sensitive grammars, and these are grammars where to resolve an expression, you can't just look at the previous expressions. You actually depend on the context in a potentially bidirectional way. Okay, so you are obliged at some level to have the full output first before you can check the validity of your syntax. So what is it applicable by? Well, by syntax pointers, think ASTs. What is it applicable to? Languages such as TeX, LaTeX, Markdown, Python, C, a lot of programming languages in general. Okay, so here we have a little visualization of what constrained decoding might look like. Okay, this is a figure that I took from lmsys.org, compressed FSM, FSM for finite state machines. Okay, so here we have a JSON schema expressed as a regular expression, right? So we have three keys, name, age, house, and the values are expressed as regex patterns. So for example, for the age, we want it to be a digit, at least one digit between 0 and 9. That regex is often implemented as a finite state machine. So you get your states, here's the states from 0 to 7, and then your transitions, which are pretty straightforward here. It's just literally the literal characters, so double quote AGE for the key, and so on, until your regex pattern here, where you are looping on the sixth state and making sure that every transition is valid with regards to the 0 to 9 digit constraint, and then you finish with a comma. Okay, so at any point here, if your transition is not valid, then there's an early exit, and it just doesn't fit your regex pattern. So this translates very well to an autoregressive generation model, because you have sequential dependencies in each token. You can just verify whether your transition, i.e. your regex pattern, is satisfied. Okay. The other thing, if you're computationally inclined, when I say CFG, when I explain that it's basically any expression can be resolved independently of context, independently also means parallelizable. So this is another benefit that you can get with constrained generation, especially with fixed schemas to adhere to, is that you can generate certain tokens in parallel. All right, so confabulation rails. Just as a little reminder, I define confabulation as, well, I didn't define it, I quoted the NLM article as mistaken reconstruction of information. Okay, so what are ways to go about, well, to mitigate or manage confabulation? Well, we have textual entailment, or also called natural language inference. That's a natural language processing task, which has quite some history already. And I'm going to explain a little bit more what it's about in the next slide, but I can give you an overview right now. Basically, you have a premise and a hypothesis, and you're trying to classify the relationship between your premise and your hypothesis, and it's usually three classes. Does the premise entail the hypothesis? Does it contradict it? Or is it just neutral to it? That's basically what your textual entailment task means. In the context of, let's say, maybe conversational agents with LLMs, well, your premise would be your prompt. The hypothesis would be the LLM's answer. And then you want to classify whether they entail each other, or if they're neutral, or whether they contradict each other. It's also applicable in larger systems, like in RAG systems. When you retrieve your chunks, you want to make sure that each chunk is entailed by the prompt, by the user prompt. That's one way to go about it. And the limitations of that, well, they are the same as delegated to the limitations of fine-tuning. Because when I say that you have live production data, it's probably out of distribution from what the model was initially, your textual entailment classifier was initially trained on. So you want to fine tune your textual entailment model on your own data in order to have more reliable classifications, a more reliable confabulation rail. And then the limitations of that will be the same limitations as for fine tuning. So out of distribution inputs, and so on. RAG could be considered as a confabulation rail, because you're conditioning each generated token on tokens that you trust. You just retrieved on your own documents, or you retrieved from hopefully trustworthy sources of data, or at least sources of data that are relevant to your own business use case. So then you're conditioning every subsequent token generation on that, rather than just counting on the implicit knowledge of your model. Another way to go about it is a little bit more recent, search augmented factuality. Search augmented factuality, we're going to see a more detailed schema about it in the next slide. But at a high level, instead of retrieving while you're searching on search engines, and you're making sure that the LLM's answer, or the factuality of the LLM's answer, is consistent with the facts that you've identified through your engine search. So through your search engine. And the limitations of that, well, SEO, that's for search engine optimization, and misinformation and disinformation. So whenever your search engine results are not reliable because they've been search engine optimized, there's propaganda online, so on and so forth. So that's going to reflect on this method's reliability. Okay. So the fourth one here, interleaving experiments. Okay, So interleaving experiments is not really something that was designed to be a confabulation rail. It's just a method of deployment. If you're familiar with A/B testing is basically dispatching to two different populations, dispatching two models to two different populations, and then collecting feedback and eventually conversion on one model, depending on which one performed better based on some business metric. And interleaving experiments, well, you're gonna have an A and a B model, A and a B result that you present simultaneously to your user, and they pick which one they prefer. Actually, ChatGPT has that on certain queries. And the limitations of that, well, it might penalize user experience, because sometimes if I have a 6-paragraph answer, I don't want to have to read twice through two versions of that. So my experience is a little bit compromised, but on the other side, it provides the developer or the provider with feedback, with preference feedback, in order to avoid inter alia, amongst other things, avoid confabulation cases. And the last one, multi-sampling consistency. So with the same language model, you can just do batch generation for the same request. Maybe you can generate 2, 3, 6, 8 different answers depending on your bandwidth, your budget. And basically you just make sure that they're all consistent within each other. The hypothesis here is that if the prompt is soliciting some information that is out of the distribution of the model, the 8 simultaneous generations should not be consistent with each other. They should all more or less go in different directions. On the other hand, if the prompt is within the distribution that the model was trained on, then the 8 generations should be consistent within each other. So the limitations of that is whenever you're using APIs that have cost per token. Yeah, you can stop me with a question at any time, by the way. You don't have to wait until the end if anyone has something to ask about. I try to deliberately keep little blanks here and there.
So far, there haven't been questions in the chat, but I'll let you know.
Awesome, thank you. All right, so as promised, examples of textual entailment. So here, the premise is the children are playing in the park. Okay, the hypothesis, there are people at the park. Obviously, there's an entailment relationship here because, well, people contain the group of children. Okay, so all the doors were locked. The hypothesis, one door was open. The label here would be contradiction. All contradicts one. Okay, so Jane is reading a book. Hypothesis, Jane is enjoying her book. The entailment here is neutral because the fact that she's reading a book doesn't necessarily mean that she's enjoying it. So you could imagine the premise column as the prompt to the language model, and you can imagine the hypothesis as the deduction or the inference from the language model, and you're trying to make sure that there's at least either a neutral or an entailment relationship, depending on our use case, but probably you never want contradiction. Okay, so I said something earlier about search augmented factorial.
Okay,
Yeah.
there you are. Yeah. You got the question already?
Yeah. Okay, yeah. I thought there was a question, sorry.
Sorry, there's a question in the chat about, elaborating on search augmented factuality versus RAG.
Oh, okay. So I didn't have the chat open, so I didn't look at it at all. Okay, so maybe this one will answer the mentioned question. Okay, so search augmented factuality, what does that look like? So at the input phase, what you have is a prompt. So what is the Eiffel Tower, for example, and then you have the LLM's response. The Eiffel Tower is a tower in Paris. It opened in the 20th century. The Nile River is in Egypt. Okay. So by the way, this is all of this pipeline is automated. You're not supposed to have any human manual intervention at any of these steps. So first step, you need to have a model to split into to do splitting into individual facts. Okay, so this could be a named entity recognition model, depending on um, what you what you tolerate as facts. Sometimes noun phrases can be enough for it. The Eiffel Tower is a tower. Okay, so that's a fact that has been extracted from here. The Eiffel Tower is in Paris. When I say here, I mean from the response. It opened in the 20th century. That's another fact here. And then the Nile River is in Egypt. That's the fourth one. Okay, so the second step, you want each one of these facts to be self-contained. So you're gonna get rid of any anaphoric or backward references, or doesn't have to be backward. Any references such as it here, when you have, for example, pronouns as well, you want to substitute them with the object that they're referring to. So here you end up with the Eiffel Tower opened in the 20th century. Okay. Third step, you check the relevance. So checking the relevance could be done with a textual entailment model, or it could be just a semantic similarity between encodings. So relevance with respect to what? Well, with respect to the prompt. So the prompt will ask about what the Eiffel Tower is, and this particular fact is talking about the Nile River in Egypt. So of course this one is not relevant, so it doesn't proceed to the next step, which is about rating these self-contained facts um, with a search engine. So here they went with Google. So the Eiffel Tower is a tower, has been confirmed. The Eiffel Tower is in Paris, also has been confirmed. The Eiffel Tower, opened in the 20th century, was not supported. So you get your final output. The two facts were supported, one was irrelevant, and one was not supported. What you do after that is up to you. It's up to the requirements of your applications. How do you want to handle this? Is this a recoverable error, or do you want to delegate to a human agent, or do you want to just abort? It depends. Very context dependent. Um, I'm hoping this answered the question about search augmented factuality.
Sounds like it did. Yep.
Awesome. Okay, so last but not least, content moderation rails. Okay. Okay. This one is a lot less visual, so I apologize if there's just a lot of text. Yeah, I'm still learning how to make actually readable slides. So the first column, how do we handle what content moderation is not a new task at all. Facebook and basically, I think it's probably as old as forums and whenever you had things like Stack Overflow. So at first, of course, it was done manually by humans, and eventually you want to automate that, especially at scales like Facebook, like businesses. So toxicity classifiers, well, they're just classifiers trained usually on binary outputs, except if you want to have a whole taxonomy for toxicity. But at the simplest level, it's just is this input toxic or not? And the limitations of that were their classifier limitations. Okay, so the second rail here is personal identifiable information detection, PII detection, with named entity recognition, and you can just go as simple as regex. Okay, so an example of personal identifiable information could be names, could be dates, emails. So dates and emails are pretty easy to detect with regex patterns. Maybe you want some fuzzy matching as well if there are typos. So it would be a little bit unfortunate if your email detection regex pattern didn't let a personal information leak just because there was a typo and the @ or the .com or whatever was not correctly detected. So maybe fuzzy matching, soft matching could be something to consider there. There are edit distance metrics, Levenstein distance, so on. Named entity recognition, you want to be able to detect nouns, titles, geographic places, addresses, and so on. So nothing too fancy here. These are very battle-tested techniques. Limitations of named entity recognition and regex are the limitations of the PII detection task. Okay. Now, as far as malicious prompts detection, well, once again, you need classifiers for it, and you need to write the in-distribution training data for your classifiers to be reliable online. And one other way to go about it besides classifiers is just similarity to adversarial prompts. So basically, you have an entire database of collected adversarial prompts, and you just calculate the similarity between them and the current prompt. And if it passes a certain threshold where you can either reject it or have a predefined answer to react with. So the limitations of that are out of distribution or out of domain adversarial prompts. So any adversarial prompts that your classifier is out of distribution from, or that your database of adversarial prompts just isn't aware of at all. Okay. So another content moderation rail, a dialogue policy via system prompts. So this isn't. This is like probably the most, maybe the least effort one. It's just about a system prompt. You can think about Anthropic's constitutional AI prompt, or once again Anthropic's Triple H prompt, honest, harmful, honest prompt, where it's just literally a set of do's and don'ts for the assistant model. Like you have to be helpful, you cannot be harmful, but you can't let I don't know, some other things stand in the way of your utility, but so on and so forth. A list of do's and don'ts. The limitations of that, well, they're nuanced contexts. Even with the Triple H prompt, I remember this anecdotal prompt where it was, I think it was pretty known on Reddit at the time, where the user asks Claude, I believe it was Claude 2, can you help me kill a Linux process, please? I forgot how to do that. And this system prompt considered it harmful just because it had the word kill in it. So nuanced contexts are the limitations of system prompts. But then again, you can iterate on the system prompts and make them better. Now, Claude Anthropic models give the right answer on how to kill a Linux process. Okay, so
While you're at a moment, there was a question. Do you have a link to these slides so people can sort of follow along themselves as well?
oh yeah, sure, that's a good idea. Why not? Give me a second. Let me see if I can. Can just copy this link. Anyone with the link can be a viewer. Here we go. There you go. I just pasted it in the chat.
Awesome. Thank you.
You're welcome. All right, let's see. Okay, cool. So the last content moderation rail is basically about whitelisting or blacklisting use cases with intent classification and topic modeling. Okay, so this is also called query routing. So right after your query, you're going to have a classifier onto your defined set, closed set of classes, which map to your intended use cases, and you just exclude everything else. This is a great exercise because it materializes what you're actually looking for, what you're actually trying to accomplish, as opposed to trying to just do everything like OpenAI or Anthropic do, which aren't necessarily bad things, but not everyone is at that scale of operation. So whitelisting the use cases is a very good way to go about it, in my experience in the industry, as well as topic modeling. You could blacklist particular topics if your service is about helping customers with buying clothing articles. You could blacklist the topic of politics. You don't wanna have to deal with political prompts. And once again, topical modeling, query routing, intent classification, they're just classifiers, so their limitations are the limitations of classifiers. Let me get back to full screen. Here we go. Okay. So on the upper left corner, we have an example of an intent classifier. So if you have the message hi, the intent here is greet. I want to register on the job board, register. Are there any jobs available near Chicago? That's a job search, etc. And the last one, hey, are you a robot? Well, it doesn't fall within any of the whitelisted use cases, so this is out of domain. What you do after that is up to you. Just delegate control to the underlying application. Uh, that's very context dependent. How you want to handle that, but at least you didn't risk yourself. You risk your company, lose reputation with whatever the LLM, the downstream LLM that decides to answer, to reply with. Okay. So on the lower right corner, maybe I should zoom a little here. Okay. So this is an example of an application with PII detection. Okay. So you send the data through a privacy layer first. So the prompt here is extract the name and amount, invoice to Nadia, amount $100 on the date of January 26th. You have a PII detection module here, which probably involves regex patterns and named entity recognition. So here it detects that 26 Jan is a date, that Nadia, that's probably an NER model. Nadia is a name, so it substituted the actual name, and it also masked the date. So this is what your LLM local one or API, remote API one, actually sees. It never sees the name Nadia nor the date. It does what it's asked. It does the extraction, i.e. it extracts the name and amount, and it returns the name masked and the amount, which isn't a private information in this particular context. It returns them to privacy layer. The privacy layer does the reverse substitution, and we get back the original name and the original name Nadia. And this is what you as the user finally see without exposing your private information to the remote API. All right, let's see. I'm seeing a question in the chat. Would you consider confabulation to be a subset of hallucination? Well, I've seen different definitions of hallucination in the literature. There are those who define it as well. First of all, I've seen this recurrent taxonomy of intrinsic hallucination, extrinsic hallucination. Yeah, extrinsic hallucination is when you want to when it's hallucination about when it's lacking word knowledge, basically. Okay, so you're just gonna pull knowledge or information that is outside of the intended context, as opposed to intrinsic hallucination. I've also seen definitions of hallucinations and as basically whenever the information in the output is not grounded, is not factually grounded in the input. So the output could be correct. Okay, you could have actually useful UX enhancing information in the output, but it would still be considered hallucination just because it's not grounded in the input. So in that sense, there are also desirable hallucinations. I see confabulation as the definition I showed earlier, mistaken reconstruction of information. And that's basically what an LLM is trying to do. So it's trying to reconstruct what is seen in its training distribution in this new context, in this new input prompt that it's trying to generalize to. So there's definitely some overlap, but I wouldn't say it's a complete subset. I hope that answers your question, Matt. You're welcome. All right. So last slide here. Hopefully we'll still have some time for questions if there are any. Okay. Okay, so the takeaways here. Whitelisting intended use cases. It's a great first step in my experience. This is what I'm always advising customers to do. Just take a list, write down an Excel sheet, whatever, write down exactly what kind of input are you expecting and what kind of associated output you want for that input. Okay. Enforce that whitelisting with guardrails. Okay. Iteratively expand the list. It's okay to dream big. It's better to start modest, and you can expand the list as you go. Think about structuring output by default. Even if your use case doesn't involve JSON, XML, whatever, there are also structures in well, in natural language. Okay, structure is also about paragraphs. It's also about hierarchical summarization. Do you want to start with summary of summaries? Do you want to go into more detail gradually? Do you want to answer a question with the maximum amount of detail first and then abstract away? So these are also things that are considered structure in natural language. And you have syntax for structuring paragraphs, for I don't know, deciding what kind of font, what font size you want. Do you want to go italic, bold? It's called Markdown. Okay, so that's also something that you can use as a guardrail to make sure that it adheres to the user experience that you're trying to accomplish. Okay, so if we zoom out a little bit, it's not just about guardrails. So guardrails are online. Okay, evaluations are offline. Guardrails are really when your model is live in production and it's dealing with user requests. Evaluations are something you want to do prior to that or also after, and also after. Okay. The guardrails validate the inputs and outputs to the model. The evaluations validate the actual model. Okay. And the highest inductive bias is still the training data. So that's still your biggest source of risk. So whenever you're using closed remote APIs, you still having some degree of confidence in your provider, as opposed to using a model where well the data training data is open and you can have some sort of risk analysis applied to it. That's pretty much all I have to say. Thank you all for listening, and I'm open to any questions if there are any.
Awesome. Thank you, Ahmed. And at this point, we'd love to move into discussion. So if folks want to raise your hand to come up on stage, we can kind of have a conversation around this as well. The link is in the chat, RJ45. See. Scott, I think I invited you up. You should be able to click to accept. Ahmed, Sasha has a question about what guardrails you use. Yeah, outline. We talked about outlines in a previous one of these sessions, which is a great way to put that first quality of guardrails in place around outputs. Scott, welcome to the stage.
Hey, thanks. Thanks for the presentation. This was great, Ahmed. I have a question around, like, one of the things that we've been thinking a lot about is kind of non-conversational parts for guardrails. So, like, I've seen a lot of examples, and I think, like, thinking about this from, users coming to a site, putting in a request, and then kind of protecting the streaming output. Have you seen anybody kind of using guardrails kind of on the side, or like other kind of architectures for maybe you're not giving a user direct access to an LLM, but there's a couple hops, or there's an LLM somewhere in the like chain calls?
Yeah, guardrails are not just for safety reasons. Like it's not just for the public relations part, but it's also for the quality control part. So quality control involves also optimization opportunities. So for example, if you have a query router, an intent classifier, well, maybe after a while that you're after some period of production time, you've noticed that there are a few categories of recurrent requests. Okay, they're just differently formulated, so you probably want to route them to the same canonical form, and that's a way where you could react by using predefined answers. So you don't even reach your LLM. You can have predefined answers. You can have optimized models that are really specific to those kinds of questions. So the LLM, I wouldn't say it's a fallback. I wouldn't say it's the bad scenario, but the more defined your task is, the more you have optimization opportunities, as opposed to being OpenAI and trying to handle everything. That's the most part of the spectrum.
Got it. Cool. Thank you.
You're welcome. Thank you for your question.
I'm going to bring in, so Sasha was talking or asking questions around the difference between outlines and instructor. And I think both of those libraries fit in this syntactic Rails space that you talked about. Outlines essentially constrains your token generation, whereas instructor does a validation after the fact. If I understood your presentation correctly, that would probably mean that outlines would only work for context-free grammars, but is that accurate? And can you sort of expand on those two approaches?
Yes, correct. Whenever you have a constrained decoding approach, you're still dealing with autoregressive models. So any language that requires full awareness of the context in order to resolve its expressions wouldn't be true compatible with constrained generation. In my experience, the other the determinant of whether I go with outlines or instructor is maybe am I using local models like Hugging Face models, or am I using remote APIs? If you're going with local or Hugging Face models, outlines is probably where you want to go. If you're if you're going with Anthropic or OpenAI, instructor is great for it.
Yeah, I have a hypothesis that OpenAI, their structured API, since it never seems to mess up, it's probably using something like outlines underneath the hood.
Highly likely.
Anyway, sorry, Yikes,
Yeah.
go ahead.
Oh yeah, so as far as I know, outlines will work on both external hosted APIs and local models, but I haven't like delved into that too deeply.
However, instructor, as far as I know, would not work with Hugging Face models, I think.
Yeah, I think that might be accurate. Yeah, the one that I am familiar with and use for pretty much everything is outlines, largely because of yeah, sorry, I was like multitasking, so I'm not sure if I understood the use case that is like a non or like the use case that doesn't use CFG versus the one that does. Um, but yeah, my understanding with outlines is that it will take the available dict of tokens that the model can generate, and then it will take the restrictions that it's received, then slash the dict accordingly, such that the only tokens the model can output are the ones that are defined in this restriction that outlines is providing, and then I believe there's something a component in which it actually like uses logic bias to kind of enforce that.
Yes, 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 that's exactly what it is. You're just gonna apply like a minus big number logic bias on any token
Mm-hmm.
that doesn't comply with your regex rules or with your other sorts of rules. Yeah, it's as quote unquote simple as that.
Yeah, so to flesh that out a little bit more, if we think about these LLMs, remember, under the hood, they're doing a few things, right? They encode your stuff into tokens, they run it through a whole bunch of neural nets, they output a set of logits, which are probabilities of what the next token is, and then they pick one, and then they decode it. So this token restriction approach is operating inside of that sort of phase. It's going at the level where you have this set of logits, which are probabilities of next tokens, and it essentially applies what I would think of as a mask, where it says, okay, here's a whole set of tokens that are just not viable because they don't match your regex or your structured output, your context-free grammar, however you're describing it, you're thinking about it, like these are invalid tokens for the type of output that we're doing. That reduces your set, as you were saying, Ahmed, to like, here's these remaining viable tokens, and then it does the choice. So it's kind of an insertion in the last layer of what the LLM is doing.
Yeah, they actually have a section in their README about CFGs. So yeah, you can use Pydantic or JSON or type restrictions or CFGs or kind of however you wanna approach it.
There was actually, I think Yikes, you actually recorded the previous talk we had that was on this. So let me see if I can dig up the links for that.
Yeah, in what they're calling eBNF format here. eBNF is for extended Bacchus-Knorr format. I'm probably butchering the pronunciation, but BNF is a formalism of CFG. It's a way to express CFG, and the way to express it here is via regex patterns and extended. I'm not sure. I guess it's more extended in the base version of BNF. Llama CPP uses the same approach. They have constraint generation as well. They call it, I think, there's probably George Ganov's name in that acronym somewhere. I think it's GGNF, something like that.
Probably.
Yeah, and to flesh out, I think what's confusing here is when we talk about generation, there's a lot of things that could be conceived of as generation. So it's after you generate the logits, but before you choose the token, which is, so you're not, it's before you generate what is the final token that's being output.
Yes,
as compared to instructor, which waits until you've generated your whole list of tokens and then tries to parse it and say, is this valid?
Yeah. So instructor, that's more the validation. If I go back to the first slide, that would be the second point. So validation for context-sensitive grammar. So you need to actually get your full output first before you parse its syntax.
Yeah, so there's some with regards to the OpenAI API. I know that that the API does have a field where you can pass logit bytes in with your request. I'm not exactly sure how it works on the back end, but I know there's a couple of like LLM front ends that allow you to input logit bias for certain groups of tokens. So the Outlines uses the same mechanic as far as I'm aware. I could be mistaken, but.
Yeah, you can do that with it's true. They have a logit bias flag or parameter for you to maybe penalize or boost certain tokens in the vocabulary.
Okay, that answers my question because now that I remember, OpenAI do have a logic bias. Yeah.
Cool. Yeah, but I think you have to pass that in with the query, right? You have to send it in with the prompt, so you can't adjust the logic bias per token, which is what you'd need to do with a context-free grammar or whatever. But I mean, they have a little outline I read once on how to use it for classification. So you have like, you just pick some tokens that represent your classes, and then you can bias so you only get those tokens back. But that's like you're passing in the logic bias in the beginning of the prompt, and so you have no way to update it as far as I understand.
Yeah, that's my understanding too. That's if you're expecting specific answers like yes or no. If that's all you're expecting in your pipeline, that's one way to go about it.
From what I've seen, though, their function calling interfaces seem to be reliable about respecting the JSON schema that you provide, which implies to me that they internally are doing some form of this.
Yeah, I think you're right. I think they have to be doing something like outlines internally as well. Yeah. It would be nice if they expose that. That would be cool.
I'll drop off the paper here, which kind of the outlines folks like kind of go pretty deep on like the how from a theory perspective, like here's all the guts of everything. It's like very open source, which I like because there's a code and then there's paper that is like here is how we got to all this code. So if you're kind of like confused on some aspects of how that one works, there's a paper to read too.
Yeah,
Well,
there
I
are
didn't
actually a
understand.
lot. Oh, sorry, go ahead.
Oh, I was wondering, I didn't understand the person RJ45 said what he said about like the context-free grammar bit. If you don't have it in the prompt, then it's hard to. I didn't understand that comment. If it could.
Yeah, yeah. No, a context-free grammar doesn't. It's not about the prompt specifically. It's more about the structure or the language that you're trying to structure your output into. So if you're expecting a JSON as an output, that's JSON is a language that can be considered as a context-free grammar. So you can use something like constrained generation, i.e., outlines for a JSON output or JSON mode for OpenAI and so on. On the other hand, if you're expecting an output that's like in Markdown, or if it's code generation, or if it's LaTeX for mathematical expressions, then constrained generation is not going to be able to help you with that. Because in order to generate the next token, you need to be able to be aware of the entire context for that next token to be correct. It's not enough to just generate it independently of the other tokens.
Just hopefully it doesn't sidetrack too much, but could you give me an example of like a use case in which like outlines should not be capable of providing the output that I want, and then like where the failure point is?
Yeah, any context-sensitive grammar, any language where to correctly predict the next token, you need to be aware of a fuller context. Like, let me go back to this slide here. So this is the slide for context-free grammar, right? So in order to adhere or be compliant with this JSON schema, like for the first curly bracket, the first double quotes, I don't need to be aware of anything else. Like at the limit, I can even generate these in parallel. There isn't really any sequential dependency between knowing that I should start with an opening curly bracket and finish with a closing curly bracket. Same thing for resolving these regex patterns. Here I just need something, a string that's at least one digit between 0 and 9. Here I just need a string that's either Gryffindor, Slytherin, Ravenclaw, or Hufflepuff. So these are what makes JSON a context-free grammar, because they're expressions that are independent from each other. I can just generate these tokens without necessarily being aware of the previous ones.
So I think there's an easy definition for that. Anything you need a stack for, right? So like a context. So any Turing-complete language cannot be represented with a context-free grammar. So
Yeah.
I think that's the. So I wanted to respond to Sasha really quick. So I think that my intuition here is that you're marching through the tokens one at a time, and you're obviously generating like, and so you have to make a decision at every token, if there's some set of valid next tokens. So you juice the logits so that you can only accept those, right? And everything else is out. But then you generate a token, now that list is completely changed, right? And it changes and changes and changes every time. So whereas with the API, I can just send it a list, like here's the ones I want, here's the ones I don't want, but I can't change that for every single token. That's why I think that the Open API wouldn't work
Awesome.
with outlines. Yeah.
I'm going to have to wrap this. Thank you to everybody who participated. We are just about at time. Ahmed, awesome. Thank you so much. Looking at topics for next week. Yikes, are you going to be ready for that long delayed transformations topic?
That's a very good question. I
And also
I
drop our
regrettably
topic
had to
spreadsheet.
go get a job and make sure I don't run out of money or food. So I depending on how busy I am with that, then we will see
All right.
as to what I can do. But
I would love to have so totally understand your constraints and would love to have a hard talk topic lined up. So I just dropped our spreadsheet of topics in the channel. Does anyone have a topic they would be excited to lead a discussion on next week so that we can leave Yikes with his flexibility and actually not force him to do work for us while he's just starting a new job?
I might have time. We'll see. But you know, a backup would be ideal.
Yeah, let's get you ready sometime, and then we'll schedule you.
Sounds good.
Quick question. These are the topics that hasn't happened yet, right?
So
I can just
topics
pick
in
one?
here, if they do not have a date next to them, they have not happened yet. Some of them don't have people who've signed up to lead them. So if you see one, these are suggestions. You are welcome to put a suggestion in here if you would just like to have somebody lead it. You can find one that doesn't have a leader next to it that you would like to lead a discussion on and happily do it. And you don't need to be an expert on it today. I know both Yikes and Manuel have talked about signing up for one of these as a way to force themselves into learning a new topic. And actually, I think Nuvik may have done that as well.
So, what about like row 13? It says after February 28th. Has it happened yet?
That one is already. I think that one did happen. So
Okay.
I don't remember. I think that got rolled into the one that Alessia ran. So we can remove that. Sorry, this is sort of a noisy, just working document.
It looks like Manuel's got something that theoretically could be the backup.
All right, we can. Since I got to wrap at 2, we'll go with that. If anyone else is excited to speak about something, don't hesitate. Sign up here, ping in the Discord. We're all good. Thank you again to Ahmed for leading today's. Thank you all for showing up and participating. And we'll catch you next week at our next AI in Action. Cheers, y'all.
Cheers.